and challenging to get replacements for. So an item that was in question following the incident, so it's one that we took a good long look at. But what you're looking at here is the sedimentation built in around it. The picture on the right is February. The picture on the left was a couple weeks ago. If you look really far in the back, you can see control cabinets. There's control cabinets that sit in these regions on the transformer. And then you see the same control cabinets back here. It gives you an idea of the sediment load and the amount of dirt and debris that was the powerhouse top deck. And the digging efforts that went into this, it was not a straightforward digging process, bring in an excavator and a dozer and start ripping and slashing. It was all detailed precision digging to prevent all the superstructure, all the conduit penetrations, all of the other ancillary equipment that you didn't necessarily want to destroy while you were digging that equipment up. So once we got the sedimentation dealt with and we got rolled back a little bit, we got to look more toward powerhouse and other equipment associated with actual powerhouse. So here's an internal shot of our powerhouse that was taken last week. As you see, the mud and the dirt is largely gone, and it looks a lot like powerhouse. We have a tremendous amount of subsystems restored at this point in time. I have a detailed list near the end of this. But the majority of the dirt and mud is removed from the powerhouse, and the majority of our subsystems and ancillary systems are online and ready to run. The lighting systems were spectacular to get those going, and it was a huge moral victory there, but then they just kept coming, and there's a lot of victories on that front. Once the site was clear and we were in a good position to move into detailed testing, we started doing some detailed testing, and that's where we got into some of our GSU or generator step-up transformer testing, and Navjot will cover the details.
Thanks, Aaron. Good morning. So I would like to go over our high voltage apparatus in our 230 kV yard. So I would like to go back a little bit. What is it? Why is it important? And what we have done with this. So this is called a GSU step-up generator step-up transformer. So both of our units are 13.8 kilovolt generators. That's the voltage they output. We cannot change it because of the physical limitations of the size of the generators, RPMs, that kind of stuff. So the line we generate to or we are attached to is a 230 kV line transmission that's accessible to us at the Yuba-Water at a Colgate powerhouse. So to bring the 13.8 to the 230 kV kilovoltage, we need equipment. This equipment helps us to step up that from 13.8 to 230 kV, and this is the most critical equipment in any power generation facility in anywhere, any kind. So this is important equipment. So we, along with this, because it's critical, expensive, and complex equipment, along with that, it's also due to supply chain issues and all of that stuff. There's lead times are like 5, 7, or 8 years long. So that was the reason we should we discussed in-house and decided that we should test this item as soon as possible. So we contacted the manufacturer of this equipment, which is Siemens Energy, and we brought them on board, and we did the comprehensive testing of this equipment. We did the electrical testing, protection testing, oil tests, control tests, and all the other inspections. So everything came out good. Unit is ready for the service with some minor repairs, which we will talk about in a little bit. So this is our second most important equipment. It's called SF6 breaker, sulfur hexafluoride circuit breakers, basically. They're like very famous in high voltage class breakers. These were, as you can see, these were submerged in debris and water. So we decided those are the final contact point between GSUs, generator step-up transformer, and to the transmission line. This is a protection device. In case of fault happens, grounding happens, this is the device supposed to trip and disconnect everything. So we tested this. We did a complete comprehensive testing, electrical, mechanical, functional testing on these bushings, contacts, everything. It tests good, and it's ready for service with some minor non-critical items. So these are the snippets taken from the final results that we have received a couple weeks ago. And these are OEM words that these equipments are ready for service. There's no structural issues with the devices on all the windings and core. Testings are good, and they can be put back in service and energized, along with some minor issues that we ran into, like we found some debris in the conduits, which we need to clean, some heater issues, and some coolers needs to be cleaned additionally. So we're working on those job plans, and these issues will be taken care of in coming weeks. Well, I have a...
Yeah. And the other high voltage apparatus that we have is obviously both of the generators themselves. And we have test plans that are commencing on those right now. The last 2 weeks of September, we're going to be running testing on these generators. A couple of interesting points. The generators themselves did not experience any mud, debris, or debris flow ingress. They stayed in general watertight for the most part. Minor seepage around the sides. Everything you're seeing in these pictures is surface rest type condition from high condensation. It was exceptionally humid. It had no ventilation for a number of days, over a week. And that condensation caused it to look like rain in the facility. So in short, it got rained on, even though it wasn't raining at the time. It's condensation water. Some of what you're seeing there on the right is our excitation system, or exciter, rotating DC generator that sits on top of our main generators. And it's got a lot of surface rust on it, and the cleanup process for that has begun right now. Testing for all of this equipment, as mentioned, is in late September. Over on the kind of the bottom picture in the middle, that's the bottom half of the generator. And those got hit with considerably less condensation type activities because they were more insulated, or it wasn't as much temperature fluctuation down there, which less condensation on the surfaces. So all tentative items that we've tested look really positive on it. We retested these, and they look good with a couple of service items needed. So a summary of systems that are online, because I've mentioned a couple of them, haven't mentioned a couple others. So let's just start running through those. All of our heating, ventilation, air conditioning systems are online in the station and running in its normal position. Air handling, bulk air around the facility is running. All of our programmable logic controllers, or PLCs, for our governor system are on, energized, and running. Digital excitation controls are on and fully energized to the controller, not to the rotating apparatus. Station service water is running, and that was a huge win. Nordic recently was able to get one of the sediment fans pushed back farther and clear, so the station does have clean station service water again out of the Yuba. Vibration protection systems are all back online. Our PG&E alternate feed, we're on normal power feed through our third means of powering our station. With both units down, we have utility power feed. Fire alarms and fire suppression systems are on. Septics and restrooms, huge win, and that one is fully operational. Microwave, that is our microwave communication system, and that is all operational, and Colgate's back online and its communication network. Cameras, lighting, and security. The elements that were not damaged are online. There's a number of lighting systems on the top deck that no longer exist. Those circuits are still being worked through. Our resistive temperature devices, or RTD systems, for all of our temperature monitoring is ready to operate as it sits today. And our plant PLC, which is our RTU, or our data concentrator that takes all of our field data and sends it into our SCADA system, all of that's operational. Station compressed air, auxiliary cooling water, our governor hydraulic power units, our large oil pumping power is back in service. Battery systems are energized, and all of our station service transformers have tested good. Long way of saying that is almost every system in our plant is operational and available to run if needed. So then I guess the next question is, what's next? What else do we have to do to make this station ready to run? We have a structural evaluation pending. Our station was loaded with a tremendous amount of debris on our top deck. That caused a lot of load. So it's just a verification that the structure is still fully sound. All indications are it is. We don't see any tension cracking, any type of challenge with that, but to document it, we're getting an independent structural evaluation group. Ground grid testing. We had some elements of our ground grid that were disturbed and modified in this. So we're going to be running a comprehensive test and a possible rework in select areas of our grounding system. Generator testing, scheduled the last couple weeks in September, and breaker 212 testing, which is one of our power circuit breakers, and it sits on our unit 1 side. The previous pictures you saw were on our unit 2 side. And that testing is unscheduled, but we're proceeding quickly on it to try to get it scheduled quickly. And then a handful of punch list items that we need to button up the station and bring everything back together. If a penstock was available to run, and just a gut estimate on this one, we're in the days to weeks category more so than the weeks to months category for bringing all of the station back in service. And overall, with the magnitude of the event, we got really, really fortunate. The number of systems that were able to be restored without requiring major rework, tested and verified, and they are working systems. So that is all we have. Are there any questions?
I'm going to make the first comment here, Aaron, is you guys are engineers, and so you gave us a very engineer-like presentation here, but we should all just be really excited about all of that news. That, you know, I can remember watching the TV reports that evening of February 13th and visiting up there a couple of weeks later and just see, you know, I was overwhelmed with and wouldn't have known where to start. And so to be at this point now, you know, being pretty confident that that plant is almost ready to run again is just, that's very exciting to me, and we all should be excited about that. So anybody else from the board? Gary.
Through the chair, yeah, just wanted to really echo those comments. I mean, this is just outstanding news, and I know we've seen kind of bits and pieces of this as we moved along, and things looked really well. Looked like things were in decent shape, and this confirms a lot of that. And so it's just super exciting to see this, and thank you to all the folks that have been working so hard on this, and I'm really happy with these results that you presented today.
Through the chair. Thanks for the report, and please thank everybody up in the powerhouse for their hard work. Without you guys doing the job that you do, we could never be here. So thank you.
Rennick?
Through the chair. Yeah, I just wanted to kind of thank you for future-proofing our recovery efforts, right? It's one thing to clean all the sediment up, but it's a whole nother thing to test each individual system. When we come back online, it's going to set us up for success and no surprises kind of deal. So I look forward to seeing the last few items come up, and I think the remaining debris removal and cleaning out the conduits and drying things, and I think you'll probably have all sorts of more testing to do after you do all that. But once you get all that done, we'll feel a lot better about coming back online when the penstock's resolved and we're ready. So thank you guys for future proofing, and let your teams know that we all do appreciate all the efforts.
This is Charlie.
Yeah, Charlie.
I would like to comment that we have a tremendous amount of money in the county treasury, and the difference between the county treasury and the 2 years is a huge amount of. So I would like to make sure that we are reviewing the way to maximize our income on the money that we have in the county, or And we also have some in the life account. And it seems like the life account is a huge income producer. And I would like to make sure that our staff is reviewing the income from the two-year treasuries to make
Yeah,
sure.
thank you, Charlie. Willie's going to make a comment there.
Yeah,
Okay.
Director Matthews, thanks for that. What I'm understanding you're asking is not related to Aaron and Navjot's presentation. This is to ensure that staff is reviewing our investment accounts, both at the county treasury and the LAIF account, to ensure that we're maximizing our interest income through the duration of this extended outage. Is that correct?
That's correct.
Okay, thank you, Director Matthews.
Thank you. I think John wanted to comment.
Oh, I just want to comment. Thank you not only for your presentation, but for the show or the pictures, because I've never wanted to go up there and get in anybody's way. And it's great to see the progress you guys are making and really how much and how deep the sediment was. And it's not just scooping that stuff up, you're hand digging around all that stuff. So, and just thank you for the presentation.
I think I have at least one public comment.
Tom McWhorter, Yuba County, through the chair. You mentioned that the DC exciter generator had surface corrosion. How are you, what method are you using to remediate that? Mechanical, in other words, Scotch-Brite, sandpaper, or are you using a chemical? And, you know, you got those copper windings. There's a lot of stuff on the backside that, I'm sorry, you're just not going to reach with the human hand. How are you addressing that?
Yeah, so in the excitation system in particular, they're getting pulled apart. So they're taking the whole thing apart. And then they're going to be testing component by component. And in the past, we've sent certain elements of this to rewind shops, and they will strip the insulation material back and dip it in a solvent type cleaning element and then re-insulate it.
Okay, once you mentioned that you're disassembling it, then
Yeah, it's
it's
coming
not just like, okay, well, we'll wipe it down.
correct.
Okay.
You're spot on with that.
Yeah, it's a lot more complicated than just looking at it, yeah.
Right.
I've been to the one down there, the old power plant at Folsom, so
Yeah.
I'm familiar with it.
The stator insulation system that we have in our generator systems, they're hydrophobic. So they won't actually absorb water into that material that it's insulated by. That's not necessarily the case in our exciter and our rotor. So both of those elements are being looked at in a much different lens than the stator system.
Thank you.
Thank you, Tom. Any other public comment? Willie?
Make sure we don't have another public comment.
Yeah, I don't think so. Go ahead, Willie.
So Aaron, you're not going to get away so easily. Thanks for the presentation. You and I have had a discussion about like long-term outage, long-term duration, and how we manage the equipment. Now that we know, let's call it 90% of it is proven good, but we're going to be out for a year or more. And then the Board of Consultants has asked us for a detailed winterization and storage plan. So you and I have talked about we need to treat this plant now that like it's online, like it's an online plant, even though it's not spinning and generating. Now that we know everything's good, we need to treat it like it's online. So kind of explain to the board, one, the winterization and storage plan you're working on now, and then how we will manage this plant for the next 12 months or more.
Yeah, absolutely. So long-term storage on any piece of equipment that you're expecting to run in any capacity is always exceptionally challenging. Very similar to your car. A car that doesn't run is a car that doesn't start when you need it. So a lot of that winterization and storage plan is going to be keeping systems online, keeping our governor systems cycling, keeping our heaters running, keeping our dehumidification running. And large generators like this, when they become so massive, they're subject to material creep if they sit in one spot for too long. They have to stay moving. Same as a flat spot on your tire. If it stays parked too long, we need to occasionally rotate it and keep our generator moving. It will likely require more maintenance in the next 12 months approximately than it does while it's running. While it's running, largely we can do quick checks, monitor sensor outputs, and we know we're good. Now we're going to have to actively do more management of that asset in the time that it's down. But that will keep it to where when we're ready to press the go button, it'll give us assurance that when we press start, everything will work correctly.
Thank you.
So, Chair Bishop, I'll just add to this. I've asked Justin, Navjot, and Aaron to give a presentation on the powerhouse itself. In the last few weeks, we did receive the electrical equipment testing that Aaron and Navjot went over, the transformers and the breakers. I wanted the board to hear what I've been telling you the last several months is our initial testing showed that things were good, but bringing the third-party engineering team or the third-party manufacturer out to verify that, I think, is what we received in the last couple of weeks, and Aaron and Navjot focused on that. So we wanted to get you that kind of verification that things are good, and then also have Aaron run through all the subsystems that are testing good. This is the good news resulting from the incident. Like you said, Chair Bishop, when we first saw the video from KCRA of just the sediment and water on top of the powerhouse, I mean, I imagined inside the generator cans we were going to have mud and debris, and it was good news, and it continues to be good news at the powerhouse facility itself. What today's presentation doesn't include is it doesn't include what we have going on with the penstock. So I'll give you a brief update on that. The penstock itself is, the most damaged portion of our facilities. That's where the incident occurred, and, immediately downstream of the penstock for about 400 or 500 feet is significantly damaged. Of course, we have the forensics evaluation that's ongoing, and in the next 6 to 8 weeks, we do feel that we will get that forensics report, which will identify the root cause, that will assist in kind of the final engineering. The engineering work that's happening right now is happening through our engineering consultant, GFT. 2-3 weeks ago now, we had, we call it a design charrette, but it's basically a bunch of engineers, including our staff and myself, sitting in a room and going through a range of alternatives for the solution to restore the penstock. And we did choose a preferred alternative. It doesn't mean it's going to be the final alternative, but we have GFT looking at an overall design that we would implement at the penstock shutoff valve, anchor block, and about 400 or 500 feet of penstock and foundation downstream of that. They're in the initial phase of that engineering now. We will review that with our FERC Board of Consultants in the next few Board of Consultants meetings. And then after the forensics evaluation comes out, this preliminary conceptual engineering will turn into actual, work towards final engineering with like a 50, 90, and 100% design. So all of that is underway, and that's to say that, yes, that's the critical path, is repairing the penstock and the related facilities up at the break. But work is going on kind of behind the scenes right now, and following the forensics evaluation, all that will marry up, and we will be back here showing you what those the solution to the engineering for the overall design is. Right now, it's so preliminary, it's not really worth showing you, but I want to assure you that that work's happening.
Thank you. Okay, I think we're ready for a motion to approve. What we're approving here would be extending the emergency contracting actions.
I'll make that motion.
Second.
Yeah, I think we need a roll call vote.
Director Bishop,
Yes.
Director Bradford,
Yes.
Director Vasquez,
Yes.
Director Furier,
Yes.
Director Messick,
Yes.
Director House,
Yes.
and Director Matthews.
Yes.
Thank you.
Thank you. Willie, can we have a manager's report?
Yeah, I mean, I kind of just gave you the update on, Aaron and Navjot and Justin gave you the update on the powerhouse. I just gave you the update on the penstock repair work. So I'll just start with Bullards and our normal ops. Bullards is currently at a storage of 794,000 acre feet. It's at 1917.9 feet in elevation. We continue to deliver about 1,250 CFS through the facility downstream into the Yuba. We continue to make minimum in-stream flow deliveries according to the Yuba Accord and our irrigation demand here locally. Otherwise, work throughout the watershed is basically our typical maintenance. Our team's operating the water treatment plant and the recreation facilities. They have changed out some log booms in front of the spillway. That's just routine maintenance. The utility team continues to work on, our normal annual routine maintenance, in addition to the work you just saw Aaron and Navjot present, maintenance at the plant. The engineering team is focused on the penstock design engineering, but they're also working on other projects throughout the watershed. And we're currently starting the process to identify a list of projects that we can undertake during this long duration outage to take advantage of both units being offline. And any maintenance work that would normally require both units to be offline, we'll try and get done during this extended outage. Once we do get the forensics evaluation and the conceptual engineering further along, we will know the duration that we will be out of service. We'll know the overall cost, and then we will identify what projects on that list we can actually accomplish during this extended outage. So that work is ongoing. You would think that we would have that list ready to go. However, the last 4 or 5 months since the outage, the team has been primarily focused on what you just saw, testing and cleaning up the powerhouse itself and working on the immediate need of penstock rebuild. But now that that's underway with our consulting engineers, GFT, they can move towards non-penstock related projects and try and take advantage of this outage. With all that, we do have a little bit of a heat wave going through right now, not totally abnormal for late July and August. It'll be over 100 degrees for the next, I think, 6 or more days. We do have this El Nino system developing in the Eastern Pacific. I've reported on that. It looks like there's a strong likelihood of warm ocean temperatures in the Eastern Pacific. How that affects our hydrology, we will only find out this coming winter, but we will be prepared for managing our facility for flood control as normal. In communications and community relations, we worked with Circle to recreate a salmon expedition for a CBS 13 story to help with the fundraising efforts that the Yuba County Educational Foundation is leading. That story is scheduled to air later this week. Fox 40 and the Mountain Messenger picked up our video featuring Sean Spanny doing water quality monitoring in support of the sediment removal project at Colgate, and they each turned into stories updating our progress. Our next board meeting is August 18th, and that's all that I have, unless there are questions.
I see no questions, so we'll move to director's reports. Andy, nothing today. Rennick?
I just wanted to say thank you to Dee Dee for letting me tag along on the salmon tour recreation, or asking that I bring some kids too. So it's kind of nice. The river's flowing. It was actually a better trip than it is in November because there's some rapids, right? And the kids enjoyed it. But they're closing that gap on what it takes to keep those salmon tours going for the year. But that's just for next year, and so just keep that in your minds there when you're thinking of fundraising ideas and efforts that we could do to help a group out. Salmon tours are good for our kids. One other thing was I just wanted to say the tremendous amount of work that has gone on since the incident in February. I just can't believe that we're doing so much with our own folks, and they're working, some of them outside of their craft, running a shovel for months and things like that. And I've been involved in a couple of recovery efforts from some railroading, and it's really hard to say that any other group of people would do the same thing. So just thank you all for your continued flexibility, and we'll try to keep the lights on. So thank you.
Seth, nothing. John?
Brownsville Mountain Fair is coming up. August 22nd, 23rd. I was on Q93 radio this morning talking about it, so mark it on your calendar.
Okay.
It's all come up. I'll be in the rib cook-off on Saturday.
Gary?
Speaking of community events, the Plymouth Lake Block Party is coming up Saturday the 15th. So just remind everyone about that biggest event of the year in Plymouth Lake. So, and that's it.
Charlie, do you have anything?
I've gotten an email for the Swan Tour, so we need to have your staff work with the Swan Tour people, I guess.
Okay, thank you. Anything else? Sounds like no, and I have nothing to report. So in order to adjourn today, we're going to need a motion because we are moving the meeting over to a closed session at the F Street office. And that requires that we adjourn with a motion
So moved.
Second.
and a roll call vote.
Director Bishop,
Yes.
Director Bradford,
Yes.
Director Vasquez,
Yes.
Director Fear,
Yes.
Director Messick,
Yes.
Director House,
Yes.
and Director Matthews.
Yes.
Thank you.
Okay, then I'm going to have a goal of reconvening over there by 10 o'clock. And so the meeting is adjourned.
Tuesday on Government Watch, you can support or sponsor. Help keep the community aware with Yuba-Sutter.LIVE.